Hello, welcome to Chapter 5.5, Equations Involving Rational Expressions. And in this chapter, what we're going to do is we're going to learn how to solve rational equations. The procedure for solving rational equations. The first thing you want to do is find the lowest common denominator among the given denominators. The second thing you want to do is multiply both sides of the equation by the lowest common denominator in order to clear the denominator. Third, you want to solve the resulting equation by applying the previous methods. And four, you want to check for extraneous roots. Sometimes what happens is that the answers that you get will be undefined, so you want to make sure that none of your answers are undefined. In example number 1, we're going to solve for x for this particular equation. So let us go to the whiteboard and solve this particular equation.
We have here 5 over 3 minus 3 over 2x is equal to 3 over 2. So we're going to use a technique that's called clearing the denominator. Because when you look at this, it looks really, really complicated because it involves something that appears to be fractional. So what we want to do is we want to get rid of that fractional element. So we're going to do that by a technique called clearing the denominator. So what we're going to look for in the denominator here is we're going to look for the lowest common denominator. And in this case, we see 3, 2x2. So the lowest common denominator is going to be 6x. And what we're going to do is we're going to multiply through the whole thing by 6x, or 6x over 1 to keep things tidy. So we have 5 over 3 times 6x over 1 minus 3 over 2x times 6x over 1 is equal to 3 over 2, 6x over 1. Now remember, you have to multiply it through the whole thing, including what's on the other side of the equality sign. And then we can start canceling. So here we have 3, 6, so that's 2, so that's going to be 10x. Here we have 2x, and then 6x. Well, the x's cancel out, and that 2 goes into 6 3 times, so that'll give us minus 9. And then we have 2, 6, 3, and then we have the x there, and that'll give us 9x. So here now we have 10x minus 9 is equal to 9x, and now we have a very, very simple algebraic equation that we can solve just like any other algebraic equation that would be of this form. So we just go about solving for x the way we would normally solve for x. And we can go minus 10x, minus 10x, and we have minus 9 is equal to negative x, and this implies that x is equal to 9. And that's our final answer. So as you see, we're not simplifying this, we're actually solving it, and that is why this particular technique works, because we're solving something, and that's why when we multiply it through by the lowest common denominator, it clears the bottom of our fractional element.
Reviewing what we just did on the whiteboard, we found that the lowest common denominator for 2, 3, and 2x is 6x. We multiplied both sides by 6x. And here we do that. This clears the denominators. And 2x times 5 minus 3 times 3 is equal to 3x times 3. Then we solve as usual. So we have 10x minus 9 is equal to 9x. We put all the x's on one side and the constants on the other side to get 10x minus 9x is equal to 9. And we get x is equal to 9. In example number 2, we're asked to solve this equation. And again, we want to solve for x. So let us go over to the whiteboard and see how to do this.
Okay, now let's look at example number 2. Well, here it's a little bit more complicated because we have a lot more stuff going on. So here we have 2 over x plus 3 plus 3 over x minus 3 is equal to negative 2 over x squared minus 9. So what I'm going to do to keep things tidy is put things in brackets here so I know what's going on and I don't confuse things. But well, we're going to do exactly the same thing in finding lowest common denominator that we have in the past when we were looking at the expression. So what we're going to do is we're going to factor the things that can be factored. And indeed, this can be factored because it's the difference of two squares. Okay, so we have that. So now we're going to list all our possible factors. So here we have x plus 3. We have x minus 3. We have x minus 3, x plus 3. So we want to see what's the highest power. So we have the x plus 3. Well, we have an x plus 3 here, x plus 3 here. So all we need is the x plus 3. And that's the highest power of x plus 3 is the first power. Now we have x minus 3. Well, we have an x minus 3 here and x minus 3 here. And it's the x minus 3, the highest power there is 1. So this is equal to our lowest common denominator. So now we're going to use this, okay, to actually solve this problem or simplify this problem so it can be more easily solved. So what we're going to do is, again, for tidiness, is I'm going to put that over 1. So I'm going to erase some of this stuff so to make it clearer. Now that we know what the lowest common denominator is, and I'm going to multiply everything through by this. So I have now 2 times x plus 3, and then I have x plus 3, x minus 3, and then I have the next term, 3, x minus 3, times x plus 3, x minus 3 over 1, plus 1 is equal to negative 2 x plus 3, x minus 3, and then multiply that by x plus 3, x minus 3, and I'll put it over 1 for tidiness. So now I start doing the same thing that I did for the other problem. So I'm going to look at the factors they have in common. So here, and that's the one that's left over. I can erase this now. So now I have 2x minus 3 for my first term. Then I do similarly for here. And then I have 3x plus 3. And then here, this whole thing cancels out. And then it's equal to negative 2. So now I have something that looks a little bit more manageable. And of course, so now what I'm going to do is use my distributive property to finish this up, combine terms, and solve for x the way I would do a normal algebraic equation of this form. So I'll just go about doing that. So I have 2x minus 6 plus 3x plus 9 is equal to negative 2. So I combine my terms here. So I get 3. And I combine my terms here, and I get 5x. So now I have an equation that looks like 5x plus 3 is equal to negative 2. Wow, isn't that manageable? So now we just solve for x the way we would normally solve for x. So I'm just going to rewrite it here. 5x plus 3 is equal to negative 2, minus 3, and then a 5x is equal to minus 5, and therefore x is equal to negative 1. And there is our final answer.
Now let us review what we just did on the whiteboard. We factored what we could in order to find the lowest common denominator. And we found that the lowest common denominator is x plus 3, x minus 3. And we multiplied both sides of the equation by this quantity. And we got this. This clears the denominators. So we were able to get a regular algebraic equation that we've seen many, many times before to make it easier to solve for x. And we found that 2x minus 6 plus 3x plus 9 is equal to negative 2. And then we combined like terms to get 5x plus 3 is equal to negative 2. And we finally solved for x to find that x was equal to negative 1. Then we want to see if negative 1 does or does not make the equation undefined. And undefined, as you recall, would mean that there would be 0 in the denominator, and that's a no-no. Let's do a quick check of the denominator of our original equation and see if we plug in negative 1 for x, we get any zeros. We do not. So here we take the negative 1, we put it here in the x's, and we see we do not get any zeros. If we put in negative 1, here we'll get 2, here we'll get negative 4, here we'll get negative 8. And all of those are fine because none of those are zeros. That means negative 1 indeed is a solution for this equation. In example number 3, we're asked to solve for x in this equation. So let us go to the whiteboard and work this one out.
Now let's look at example number 3. So here we have 5 over x plus 2 is equal to 11x plus 1 divided by x squared plus 7x plus 10 minus 12x plus 5. So I'll just bracket things for neatness, okay, just to know what I'm working with. And now, well, we know that, again, we're going to find the lowest common denominator. And again, we have to factor and list all the parts we have. So in this case, if we factor this here, we get x plus 2 times x plus 5. And of course, I check it. The last term, to see the last term, I multiply it. 2 times 5 is 10. And if I add these two terms, I get 7. So it looks good. And so now I'm going to list my denominators, factors. So I have x plus 2, I have x plus 5, I have x plus 2, I have x plus 5. So now I'm going to look at it, okay, and I'm going to see, well, I'm going to multiply it through by that. So I'm going to go 5 x plus 2 times x plus 2, x plus 5, and I'll put the 1 there, as I said earlier, for tidiness, is equal to 11x plus 1 over x plus 2, x plus 5, since they're exchangeable and it makes it easier to see what's going on. Over 1, and then my last term okay. So now I start canceling stuff out because now I have it in factored form, which means we can now clear the denominator. And then now we can write an equation that is now more manageable than what we had earlier. So there we have it, and now we just solve for x the way we would do any type equation of this form. So I will just proceed to do so. Distributive property. So I get 5x plus 25 is equal to 11x plus 1 minus 12x minus 24. And then I put together the common terms. So I end up with 5x plus 25 is equal to negative x minus 23. And then finally, I end up putting everything. Remember, choose a side where you're going to put your variable, choose a side where you're going to put your constants, and then you find you get 6x is equal to negative 48, and this means that x is equal to negative 8. Now, on your PowerPoint, you will find that on the answers that you also should check this, okay, if you can. Now, of course, checking this is really rather complicated in this case. So I'm going to leave that to the reader or leave that to the student, but what you want to do is you want to go to your original equation where it looks like this and take the x is equal to 8 and put it into your original equation. So everywhere you see an x, you will put an 8 and then proceed to see if you get the same answer on this side as you get on this side. And again, on your PowerPoint, you will see that I actually worked it out, and indeed it did work.
Reviewing what we just did on the whiteboard, we factored what we could, and here we had to factor this in order to find the lowest common denominator, which we found to be this. And we use this to clear the fraction, or clear the denominators, and solve as usual. So we ended up solving this, and we got 6x is equal to negative 48, which implied that x was equal to negative 8. And we just do a spot check to see that 8 does not make the equation undefined. So we look here and we see negative 8 is okay here, negative 8 is okay here, and negative 8 is okay here. It does not make any of the denominators equal to 0. So here I do the check in more detail. And indeed, I found that everything was all right. In example number 4, we're asked to solve for x in this equation. So let us go over to the whiteboard and work this one out in detail.
In our last problem, we saw a situation where the x actually does work when we plug it back into the equation. Because if we look at the last equation, we see, or the last example, I mean, we see that the denominator, if we put any number in for x, and in the case of our last equation, it was negative 8, we will not get 0 in the denominator. And that's a good thing, because that's exactly what we do not want. But let's look at this next example. So we're going to look at example number 4. So we're going to solve 3 plus 1 over x is equal to 10 over x squared, okay? So just by looking at this, and again, I'll put the 1 there so we know the difference between what's our numerator and what's our denominator. So what we're going to do is we're going to see what our lowest common denominator is and clear our fraction and clear our denominator. So lowest common denominator is equal to x squared. So as before, multiply through x squared over 1, and then this is okay. This one we got rid of one of the x's, and this one is equal to 10. So we end up with something that looks like this. Now, of course, in order to solve this, as we learned earlier with quadratic equations, we have to put this into standard form. So I have to move that 10 over and set it equal to 0. And then, of course, I could factor. So what I do is I factor. And I find that when I factor this, after going through the whole factoring technique that I showed you earlier, because I can't simplify this, so I'll have to use the AC method that I showed you earlier. And so I find that the factors for this one are 3x minus 5 and x plus 2 is equal to 0. And then, based on the rule which we learned earlier when we were solving quadratic equations, we set each of the parts equal to 0. So we have 3x minus 5 equal to 0, and we have 2 plus x plus 2 equal to 0. So this means x is equal to negative 2. And then on the other side, we have x is equal to 5/3. So now we have this and this. So we want to now, and this is the reason why it's often so important to check, even if it's just a spot check. So, for example, in this one, okay, if I put, okay, so let's look at this for a second. So if I put in negative 2, that looks good, okay, and I put 2, 4, that looks good. And if I put in 5 over 3 here, that's good. And if I put in 5 over 3 here, that's good. And so what we see here is that neither of those give me 0 denominators. So none of these solutions give me 0 in the denominator. So therefore, both of my solutions are good. And that means that I can write my solution set as -2 and 5 over 3. And that is my solution set.
Let us review what we just did on the whiteboard. So to clear the equation of the denominators, we multiply both sides by x squared. So here we do it, and we end up clearing the equation, so we get 3x squared plus x is equal to 10. Now we rewrite this in standard form and solve. So to rewrite it in standard form, we have 3x squared plus x minus 10 is equal to 0. Then we factor and set each of these factors equal to 0. So we end up x is equal to 5/3, or x is equal to -2. The solution set is -2 and 5/3. So we see that neither of the solutions makes the denominator equal to 0 if we just do a quick inspection of the denominator, imagining substituting each of these into the denominator. In example number 5, we're asked to solve this equation for x. So let us go to the whiteboard and work this one out.
So example number 5, we have x minus 6 over x plus 3 is equal to 2x over x plus 3 plus 2. And we find that the lowest common denominator in this, because again, I'm going to do this in here, we find that our lowest common denominator is x plus 3. So now we're going to clear the fraction. So we have x over 1 minus 6 over x plus 3, x plus 3 over 1 is equal to 2x over x plus 3, x plus 3 over 1, and then plus 2 over 1, x plus 3 over 1, and now we proceed to x plus 3 minus 6, x plus 3 is equal to 2. This cancels out, so we end up with just 2x there. And then, and if we made a mistake here, that has to cancel out, so it's just minus 6. And we have 2x plus 2 times x plus 3. So there we have it. Almost forgot about this guy over here. So you want to make sure that you are careful and you cancel out what needs to be canceled out. So now what I'm going to do is my distributive rule. So I have x squared plus 3x minus 6 is equal to 2x plus 2x plus 6. So there I have that. And then, as usual, what I'm going to do is we have to set this equal to 0. So I'm going to have to move all the stuff. I'll bring these two together, make that 4x plus 6. bring everything over that needs to be bring over, and I end up with an equation x squared minus x minus 12 is equal to 0. So this is not too difficult to factor, unlike the previous one where you have to use one of the more sophisticated methods to factor it. This one is fairly straightforward, and you have x plus 3, x minus 4 is equal to 0. So now, again, I'll just quick check. 3 times negative 4 is negative 12. 3 minus 4, add them together, I get minus 1, so it looks good. And then I set each of these terms equal to 0. Is equal to 0. So I set each of these terms equal to 0, and then I solve for the x, and I get x is equal to negative 3, x is equal to 4. So now I'm going to look at this, and I'm going to go, uh-oh, problem. If I put in x is equal to negative 3 back into my original equation, what's going to happen? It's going to be 0 in the denominator. That means that this is undefined, and this is no good. But this one is fine, because if I put this in the denominator here, I'll get 3 plus 4 is 7, and this denominator I'll get 4 plus 3 is 7, so that's good, and that means that I have a denominator that's not crazy. Now, of course, I can continue on checking to make sure I get the same thing on this side as I get on this side to make absolutely certain. So it's very important that if you do not have time on a quiz to do an extensive check, make sure that you check that the denominator is not undefined, or gives you an undefined term.
Reviewing what we just did on the whiteboard for example number 5, we found that the lowest common denominator for this one is x plus 3. And we use this to clear the denominator and get a regular algebraic equation that we can solve. And we set the equation equal to 0 because we must have it in standard form, and we factored it. We set each factor equal to 0 and found that one of the factors is equal to negative 3 and the other factor is equal to 4. But the negative 3 is not good. If x is equal to negative 3, the denominator of the original equation will be 0, and this is undefined. This is why we must check. So if we substitute in negative 3 in the denominator here, we see negative 3 plus 3 is equal to 0, and here also negative 3 plus 3 is equal to 0, and that is no good. In this example, number 6, we're asked to solve for x. So why don't we go over to the whiteboard and work this one out.
Now we're going to solve something a little bit different. We're just going to solve for some variables. And as we did earlier, we're going to learn a little bit more about these kind of things in situations like this. And these were called literal equations. And that means we have, here's a situation in number 6, where we have a plus 1 over b is equal to 1 over x. So here we want to solve for x. So again, we do the same sort of thing. We want to look for what is the lowest common denominator and clear the denominator. We want to look for the lowest common denominator and clear the denominator. In this case, the lowest common denominator is a, b, x. So we multiply the whole thing through. So even though we have just letters here, we go through the same process as it would be for numbers. So in this case, we have 1 over a times a bx over 1 plus 1 over b times a bx over 1 is equal to 1 over x times a bx over 1. And now we do the same thing we did before, that we did with numbers and variables. So we have the a here and a here, bye-bye a. We have the b here, bye-bye b. We have the x here, the x there, bye-bye. And now we rewrite it, okay? So here we have bx plus ax is equal to ab. So now, as we did when we were looking at literal equations, we pull out the x, and we end up with ab plus a is equal to ab. And then we divide b plus a, b plus a, and then we get x is equal to ab over b plus a, and we see if we plug in where the x is, it's not going to give us 0, so we know that we are going to be okay.
Reviewing what we just did on the whiteboard, we begin by multiplying both sides by the least common denominator. In this case, it's abx. And here we proceed to do that in order to clear the denominator and end up with bx plus ax is equal to ab. Now we solve for x, and in this case we have to factor out x in order to isolate it, and that means x will be equal to ab over b plus a. And we can look just by inspection to see that if we substitute this in to x, that it will be okay. We don't get any 0 as a denominator, so we can conclude that indeed that is the solution. Thank you very much. Hope that you enjoyed this video. Take care, stay well, and goodbye for now.